All right. Uh, so hello everyone. I'm Apostolos Kourtis. I'm a faculty member of the University of Nicosia, and today we have a session on Ethereum and other programmable blockchains. So this is mostly a Q&A session, which follows a series of four videos which are available on Blackboard. If you haven't watched them, you should. Before I start, just to give you a bit of information on my background. So, my area of expertise is finance and forecasting, but more recently, I've been interested in digital finance, which, as I see it, concerns applications of blockchain, AI, and other emerging technologies in finance. I've published papers around blockchain adoption, NFTs, and currently I'm also involved in a large project around the ethical use of AI technologies, again in financial markets. So, as I mentioned, the topic of today's session is Ethereum. And I'm going to give you first a quick overview of what I covered in this offline um, material and the videos as well. And then we can go through your questions, your very interesting questions, I would say. So feel free to use the Q&A to ask any new questions you might have. So last week, you talked about Bitcoin. So Bitcoin has been the first and the most established, according to different metrics, blockchain, a large blockchain network, as well as cryptocurrency. And it's been alive for so many years. So, as you discussed last week, the aim of Bitcoin has been to act as money, as a peer-to-peer, that is a decentralized payment system. And because of this very focused goal, it has come with a series of limitations, intentional limitations or limitations by design, which are going to cover, which were later on recognized by the Ethereum founders and led to this invention of a decentralized world computer. So that is how Ethereum is commonly described. A decentralized, open source, transparent, and immutable, as it is a blockchain platform that is programmable. It enables what we call smart contracts as well as decentralized application known as dApps. So it started as a simple or a more simple way to add programmability to money, but since then it has been involved to a decentralized kind of internet or computing platform with applications that extend beyond money and finance, so a general purpose computing platform that does not rely on any intermediaries. So it launched in 2015, and its native token is known as Ether. It has different use cases. I'm going to go through them quickly in a little bit. It's currently the second largest cryptocurrency by market capitalization, of course, following Bitcoin. So why another blockchain? So Bitcoin by itself has focus on stability, predictability, security, as well as being backward compatible. So it has followed a very conservative approach, that is its philosophy. On the other hand, Ethereum uh, differentiated with Bitcoin by focusing instead on rapid innovation as maybe a startup would do. It focused on functionality and experimentation at the cost of backward compatibility. So this is a key difference between the two. Another very important difference is the mechanism that is used for consensus, for settlement, for example, of transactions or other blockchain activities. So Bitcoin uses proof of work. This means that in order to validate transactions, to confirm, as we say, transactions, you need to allocate computing power, hash power, which is energy intensive, but at the same time, it is tested and over the years has shown that it's very, very secure. On the other hand, Ethereum, while it also started as a proof of work based blockchain, it more recently transitioned to a proof of stake consensus. So this offers a significant advantage in being much more energy efficient. So you can save more than 99.9% in terms of energy compared to proof of work. Um, so this is achieved by instead of having miners using physical hardware to mine Bitcoin and confirm transactions, we instead use validators which secure, which actually stake Ether, the stake, the native token of Ethereum. So they need to stake an amount. So you have economic incentives instead of having hardware based requirements. So a very different approach. When it comes to scalability, both of them suffer, at least when it comes to the main layer, to the base layer. They only accommodate a few transactions per second, which is a significant issue. If you want to achieve mainstream adoption, you need a much larger number of transactions per second, minute, etc. Uh, for example, in comparison, Visa, the credit card network, it can accommodate between 20 and 80,000 transactions per second, I think. Um, so so this issue was recognized early with both blockchains, and different approaches were introduced to try to make the blockchains more scalable. The dominating approaches are both layer 2, which means you introduce an additional layer where a lot of the transactions are executed. With Bitcoin, this the main layer 2 approach is known as the Lightning Network, while with Ethereum you have rollups. Again, I will give you a few details on scalability in a little bit, but I go in much more depth in a session of week in the session of week 11, which focuses on scalability and other advanced topics in Web3. So because of the differences in the philosophy and the way these blockchains were designed, the first one has a primary role as a store of value and money, which is a censorship resistant, while the second one uh, aims to act as a wall computer where developers can develop applications that run not in a single computer, but in a network of computers. As a result, the use cases can vary significantly, with Ethereum offer a much more broader uh, set of use cases compared to Bitcoin. So a common question that I get at this point is which one is better out of the two? And some people even might consider that Bitcoin is old tech, while Ethereum is a new iteration of the technology. But this is not how things are. So these two dominating blockchain networks uh, are different by design, and you can think, as I said in the video, in the recording, you can think of one as a screwdriver and the other as a hammer. So a hammer is not better than a screwdriver, and vice versa. They are used in different contexts, in different settings, and this is how Bitcoin and Ethereum are. So at this point, I do not really see them as competing against each other when it comes especially to the use cases, even though there is some intersection between them. So Ethereum started as money which are also programmable, where you can have simple code known as smart contracts that help with holding assets and executing transfers in an automatic manner. This vision then became something bigger. So if you take a lot of smart contracts, you can create decentralized applications, which you can have gaming platforms, social media platforms, etc., all running on the blockchain. And more recently, we recognize Ethereum as a world computer, a general purpose decentralized platform, not only for financial applications, but for other applications such as decentralized autonomous organizations, digital identity, stable coins, tokenization, and many, many other both financial and non-financial applications. And it has been very, very successful in achieving this vision, as this stats in the bottom of this slide show. So when it comes to different types of applications, uh, when, for example, with financial applications, we can have cryptocurrency transactions as well as what we call decentralized finance. So, decentralized finance is a recent development in the blockchain world, which involves applications such as lending, borrowing, asset management, stable coins without having traditional intermediaries such as banks, brokers, dealers, etc. And out of this, stable coins have really exploded. They have gained a lot of popularity. To give you an example, currently I think stablecoin volume has recently exceeded 8 trillion dollars, which is huge. It's more than Bitcoin again when it comes in terms of volume, in terms of actual trading. So this is one of the main areas where blockchain has gained mainstream adoption. You can buy a Visa credit card that settles on in stable coins. You can more and more governments, jurisdictions, or even banks experiment with different types of stable coins. Most of them operate on the Ethereum network. And in terms of another financial application, we have asset tokenization, which has to do with converting real world assets into blockchain based token. Again, Ethereum leads the space here. Um, so tokenization offers a lot of advantages, especially for assets that are illiquid. I can tokenize my house and then sell it in little pieces to many people all around the world, who then might get a piece of the rent, and also trade the tokens 24/7. Tokenized bonds is also another area that has seen a lot of growth. Um, so I would say that out of these different financial applications, stablecoins and tokenization are the most prominent. Um, Something else to add about tokenization, which was not covered in the videos, it's a very recent development. Um, the New York Stock Exchange, which is the largest stock exchange in the world by a lot, they now have a platform, a facility which allows trading as well as settlement of tokenized blockchain-based tokens of real-world assets. So again, a lot of developments in this area. And we have several non-financial applications that range from digital identity to decentralized governance models for DAOs and many, many others. So quite a rich ecosystem of decentralized applications. Ethereum is, first of all, or should I say, Ethereum utilizes what we call accounts. And we have two different types of account. We have externally owned accounts, typically controlled by people, by real people, that they are used to send and receive Ether or other types of tokens, and you need a wallet to access them. And then we have contract accounts which are operated by smart contracts. They are controlled by code. They cannot initiate transactions, but they don't need human input. They operate autonomously based on the code. So you can think externally owned accounts as human citizens in the Ethereum world, while you can think of contract accounts as, I would say, robot citizens, which it's something that we might see uh, sooner than later in the real world as well. So the execution environment in the Ethereum network, which is the environment where all smart contracts run. So you can think of this as an operating system in some sense. Uh, uh, is called Ethereum Virtual Machine. So it's a global, decentralized computing engine that processes all transactions on Ethereum. So every node, every part of the network is required to run in order to maintain consensus. It's required to run the EVM. Um, and it is completely isolated with regards to access to external networks. Ether, which is denoted by ETH, is Ethereum's native cryptocurrency. And it has different types of uses. It is one of the key uses is that of a commodity, so you can think of it as a digital oil in the sense that it is used to pay the transaction fees, the gas fees as we call them, for computation and storage. So it acts as digital oil. Um, it is also a capital asset. So if you recall, validators which provide security in Ethereum, they need to stake Ether. And as a result, they are compensated with a new ether for that. So it's a capital asset in the sense that it generates some kind of flow. It's not exactly cash flow, it's ether flow in this case. And can also act in some sense as store of value. So this is something common with Bitcoin. Only in the case of Ether, most of its store of value is realized when you use it as a collateral in a DeFi ecosystem. For example, if you want to borrow to do using a DeFi platform, you might have to use Ether as collateral. It's also used in some cases to back stable coins as well. Um, and an interesting fact about Ether and a big difference compared to Bitcoin. So if you remember, Bitcoin has a fixed supply, and this is a source of value or price appreciation because it is scarce, similar to gold. Ethereum instead uh, follows a dynamic policy similar to how a central bank will try to increase or decrease money supply. In some cases, however, Ether it can even become deflationary when it comes to circulating supply, especially when there is very high network usage. So, as discussed, Ethereum used to be very similar to Bitcoin when it comes to consensus. It utilized the proof of work mechanism, but a few years ago, it transitioned to proof of stake through the merge, which is a major fork, which we're going to talk more about forks again in session in week 11. So proof of stake replaces miners with validators. Validators secure the blockchain by staking, by locking a minimum of 32 Ether. They can lock a higher number, a higher amount of Ether, and the more they allocate, the more likely they are to be selected to propose the next block in the blockchain. Uh, Then, after this takes place, other validators will then verify the block, and this is how consensus is reached. And now you might wonder, what if those validators are a bit cheeky? And they are not honest, and they try to play with the system and misbehave, etc. Then there is a mechanism known as slashing, which in essence punishes the malicious validators who then they can lose their stake. So security relies on economic incentives. That's why we also call it economic security. Um, and then consensus finality is achieved when around two-thirds of the active stake confirms a checkpoint. A key concept related to every blockchain, but is also very relevant, of course, to Ethereum, uh, is that of the blockchain trilemma. So this was introduced by Vitalik Buterin, who is the Ethereum founder, and it highlights the key trade-offs uh, in blockchain design. So blockchain networks in general have to choose two out of decentralization, security, and scalability. So you can have, for example, a very efficient, very fast blockchain, but this won't be that secure, or it will be more centralized. If you want a very decentralized blockchain or a fully decentralized blockchain, uh, yes, you can ensure security, but then you can sacrifice scalability. You can sacrifice. You might have to sacrifice efficiency. So this is a trade-off that you need to consider very carefully, uh, either when you design your own blockchain. Different blockchains uh, choose how to prioritize different attributes, or when you choose which of the existing blockchains you want to use. For example, you might fast transactions or a large number of transactions might be a strong priority to you, and you might live with a more centralized blockchain. You can think, for example, of a blockchain which is not permissionless, that is run by a consortium, let's say financial institutions, a consortium of banks, which each one has its own set of nodes. This is very far from being fully decentralized. There's a little bit decentralized, I would say, but it can be very fast. So over the years, Ethereum has adopted a series of updates, which are covered in details in the videos. And these updates aimed to um, to uh, to address this balance, or to change this balance between decentralization, security, and scalability. And we had some very recent developments about that, which I'm going to cover in a little bit. So as I mentioned, the key scalability approach adopted by Ethereum is that of having layer 2 mainly rollups. So you can think of rollups. So instead of having all the transactions taking place, being, to be more precise, to be executed using the base blockchain, the standard Ethereum blockchain, you have them being executed outside of the blockchain in a layer 2, and then they are combined all together, they are batched, and then they are transmitted to the blockchain, to the Ethereum blockchain, but the blockchain receives compressed data. And in that manner, it reduces the space requirement, it can reduce gas fees, etc. So this approach is consistent with Ethereum's roadmap. Um, and we have different types of rollups, as well as some other scalability approaches, which we'll cover, as I said, in the advanced topics in Web3 session. So, of course, Ethereum is not the only programmable blockchain. There have been others, and each one has its strengths and weaknesses. They need to consider also the trilemma trade-offs. Some of them, for example, Solana focuses on high performance. It is very fast. Others focus on interoperability, and they are like a system of chains such as Polkadot. Tezos focuses on being able to easily upgrade. Cardano follows a more academic approach. So, so when it comes to these competitors, you can see that they are more specialized. They aim to address more specific use cases than Ethereum. Uh, so, um, so when it comes to the user, uh, they need to consider the specifications that best match their use case. And before I go to the questions, I would like to close with this slide with two very recent but also very important, um, let's say, opinions by Vitalik Buterin, who is the founder of Ethereum, one of the key influencers in the blockchain space, and I would even say in the decentralized space, in Web3. Uh, so the first one was from back in January, and he said that uh, in essence the trilemma has been solved because of two technologies, which we'll cover again in more detail in session 11. But one is called peer DAS, so data availability sampling. That's what DAS stands for. And the other one is ZK, so zero knowledge EVMs. So these respectively aim to improve the data storage requirements as well as scalability and help with high bandwidth. So these are not fully live yet, so there is still, we need to wait a little bit to see how things progress. Um, Another statement that we had from Vitalik Buterin is that layers 2, and especially rollups, uh, which uh, which aim to help Ethereum be faster and scale and reduce the fees in the transactions, have faced significant issues when it comes to decentralization. So there has not been a lot of progress with them becoming decentralized as they should, according to Vitalik. So at the same time, the main blockchain, layer one, has become faster and cheaper to use, and this is expected to further improve in 2026. So I think this is a direct, a very straightforward nudge, a call for all these layer two approaches to improve themselves. Um, and you can see the rest of the tweet. For he also has some concrete proposals. So let me now progress with the Q&A. So we received many very interesting questions. Um, so because we received a large number of questions, my colleagues and I had to be a bit selective. So let me give you a few details about the selection procedure. Um, some questions were very similar, so we pick one out of them. Also, some questions will be covered in detail in the next session, so we will refer. So if you don't see your question here, it is likely that it will be covered in detail in another session. Um, so let me start with the questions. So the first question is by Gabriela. What problem does Ethereum solve that Bitcoin cannot? So we have a series of questions about Bitcoin versus Ethereum. So Bitcoin tends to be referred as the digital gold. So I'll use this analogy. So think of Bitcoin as a bar of gold, and think of Ethereum as a smartphone. Okay. So they are made for different use cases. You cannot use the gold bar to make a phone call. You cannot bury your smartphone in the backyard, and after 20 years, it will be you expect it to worth more. So they're made for different things. And what Ethereum is made for uh, is mostly programmability, and this is the key limitation that it aims to address. So Ethereum is, as we called, Turing complete, which means that it has more complete, more advanced programming features, which allow first of all, to have programmable money, but then to program applications, decentralized applications that run across the whole network. So there are many different use cases than the single focus of Bitcoin, which is to have decentralized money or decentralized peer-to-peer payments or digital gold. And this brings me to the second question, which is simplicity, the simplicity of Bitcoin a strength compared to flexibility? Again, it depends on the use case. If you want money, if this is your focus, is to have decentralized money because maybe you don't have access to a bank account in your country, or you're subject to sanctions, or you have other use cases which the traditional financial system cannot support for you, then yes, simplicity is a strength. It offers security, it reduces the attack surface, as we say, there is less room for error. Uh, so there is also the principle of there is Occam's razor, or an equivalent of that according to Aristotle in ancient Greece, who I think, I mean, in free translation, he said, the more perfect a nature is, the less means it requires. So in that sense, the simpler is something, the less room for error and security flows in this case. Ethereum is indeed more flexible. So if you want to program an application, to program a smart contracts, of course, simplicity is not a strength, is a weakness. Gabriela also asks, Bitcoin has a fixed 21 million supply. Does Ethereum's flexible issuance weaken its monetary narrative? So, if what you care is digital gold, is maybe store of value, then yes, then Ethereum dominates. Sorry, then Bitcoin dominates. So if you want something scarce like gold, then Bitcoin indeed has a stronger narrative for that. Uh, Ethereum is, I would say, more, it's closer uh, to a central bank monetary system where the supply is adjusted the money supply is adjusted, the circulating supply is adjusted based on different needs uh, of the economy, or in the case of Ethereum, of the blockchain economy. So, so the next question is about security. So which blockchain is more secure, Bitcoin or Ethereum? Ethereum right now has over 1 million validators, and Bitcoin is also the epitome of decentralization. They are both very secure, okay? So they are both super secure. Uh, Bitcoin itself has been around for a longer time, so we can get a point for that. Uh, Hash power, the hash power required to perform a 51% attack is huge. Uh, a potential concern, I would say, is that of quantum computing and how it can affect the network in different aspects. And we have to see if this threat from quantum computing is realized, and if it is realized, how quickly can Bitcoin adjust to protect from it. Ethereum uses economic incentives, so the heart of Ethereum is economic security. And again, the amount of staking required to carry out an attack is huge. Ethereum is not feasible. Um, and so they are both very, very decentralized as well. Uh, so I guess uh, in the current state and how the world is right now, there are not significant threats for both, but things might change as software like AI progresses or hardware like quantum computing progresses, okay? So which network is more resilient against state level attacks? And this question is also relevant to the next one by Victor. Could you elaborate a bit on the security risks associated with the network, given that the largest number of nodes and validators are concentrated in the US? Doesn't this put the entire ecosystem at risk? Okay, so there is some potential risk with Bitcoin would be if a lot, like the majority or super majority of nodes were concentrated, of computers or the miners were concentrated in a single country. In the case of Ethereum would be if validators that stake Ethereum were concentrated in the country. The US is an example by Victor here. So I think the key risk with uh, Ethereum is not that not so much of security, but inconvenience, I would say. So if there is some kind of regulation that puts specific restrictions on the validators, and these validators are in a specific country, then there can be issues such as slow consensus, or if the validators choose some transactions that cannot be validated, then there can be issues. There is a mechanism in place that we covered in the recorded lecture, which has to do with inactivity. So if many nodes go online, then the network adjusts itself and validates based on the remaining nodes and validators. Um, so uh, to so I wouldn't say that the entire ecosystem is at risk, but there can be significant issues affecting the consensus and the reliability of the network. So, which network is most resilient against state level attacks? The, the economic incentives can be similar in the sense controlling the hardware power or controlling the stakes required for having a state level attack can be significant. So it really depends on the state, I would say. So two questions by Peter. The first is Bitcoin intentionally uses a non-Turing complete scripting language. Uh, how does this design choice compare with Ethereum's Turing complete smart contract model from a security and an anti-financial crime perspective? So the moment you introduce complexities such as smart contracts, decentralized applications, layer 2 approaches, interoperable blockchains, you increase, as Peter says, the attack surface. There is more room for error or intentional or unintentional vulnerabilities. And as such, the Ethereum ecosystem could be more sensitive to security concerns or illicit activity than Bitcoin. Okay, and this is because there are less. There's a lower number of degrees of freedom with Bitcoin compared to Ethereum. Bitcoin and Ethereum use different transaction fee mechanism. So input-out differentials versus gas-based pricing. How do these fee structures contribute to network security and attack deterrence? Are they conceptually linked to preventing consensus-level attacks, or do they address different threat vectors? So how are fees used in these two networks? So in a nutshell, I would say that these fees are used for allocating block space. And in terms of security and attack deterrence, they're more relevant to preventing spamming in the network. It is instead the consensus mechanism, that of the proof of work and proof of stake respectively, which provide the security for preventing major attacks such as 51% attacks. Are programmable blockchains increasing AML risk compared to simpler chains like Bitcoins? Yes, you can even program dApps and smart contracts with the aim to avoid AML, so anti-money laundering mechanism. So again, this relates to the flexibility of programmable blockchains. How does Ethereum's proof of stake mechanism improve energy efficiency compared to proof of work? And what potential risks does it introduce? So the key advantages of proof of stake compared to proof of work is first that proof of stake is much more energy efficient, as the validators have to stake Ether instead of staking computing power, so by more than 99.9% efficient compared to proof of work. And another advantage of the proof of stake mechanism, consensus mechanism, is that it does not require access to significant computing power, to hardware. And those of you that follow uh, the the computer markets, you've seen that prices have exploded recently, especially and mainly because of AI models and AI compute. What is the risk? There are always trade-offs, and always have this in mind. So with blockchain designs, I mean, almost every system design, there are trade-offs. there are benefits, there are costs, there are pros, there are cons, there are returns and risks, and we always need to consider them. And the main risk with proof of stake is that uh, we can have what we call plutocracy, so those that have more stake have larger control in this network, and they compensated with more ether, so the rich can get richer. There are some approaches that try to resolve that, but this is the key risk, the concentration of validation to those that have more ether. Um, How does the shift from proof of work to proof of stake fundamentally change Ethereum's economic and security model? So we cover this in details. Uh, so, um, so with proof of stake, we have economic security. So the validators stake ether instead of computing power, and it has its pros and cons that we covered. So let me now move to a set of very interesting questions around smart contracts um, and decentralized applications. So first of all, what are smart contracts? When you hear the smart contract term, especially today, you might think of having an AI agent or an AI model uh, that uh, uh, is in the heart of the contract, and that makes it smart. But this is not how it works. Actually, smart contracts are not that smart. They are based in they're based on a very deterministic design. If this happens, then this happens. So if I receive this amount, then I will release that amount. So very, very simple approach. So a common example that we use is that of the vending machine. So instead of going to the grocery store to buy a Coke, you go to the vending machine. So there is no seller, there is no intermediary. You enter the amount, press the right code, and you receive the code. So this is how smart contracts work. Um, can you please give some specific real-world examples of smart contracts being used in practice, NFTs, and decentralized autonomous organizations? So when it comes to NFTs, the key use of smart contracts is that of so you deploy a smart contract which ensures that the ownership of the artwork, for example, of the CryptoPunk, etc., goes to the person that owns the token. So more on NFTs in the session in session in week 9, I think. And then a popular example of a decentralized autonomous organization, this very powerful idea of having a whole company, a whole organization running on the blockchain and performing tasks in an autonomous manner. We have MakerDAO, so this is like a bank that runs on the blockchain. It issues its stable coin. It has decentralized governance mechanism, voting, etc. So MakerDAO is one of the most common. It's like a collection of many, many different smart contracts and dApps. What are AMMs? So AMMs stand for automated market makers. So the idea So these are used by decentralized exchanges, which I think they covered in another lecture. But just to give you a quick overview, so with traditional exchanges, you might need market makers, you might need, for example, people dealers that sell or buy a stock, and this provides liquidity. Because of the absence of such specialized dealers in the blockchain world, especially in exchanges and decentralized exchanges, there people had the idea of having instead smart contracts, having um, uh, the code having a software-based version of a market maker which sets the exchange rate in a decentralized exchange. So Uniswap is a popular, let's say, implementation of AIMs. Liquidity pools are used by the user of the decentralized exchange to lock the token that they want to trade, and usually Ether in the case of Uniswap. And then with liquidity pools, you provide liquidity, and based on how much liquidity you provide, how much you provide from each token, you set an exchange pair. Smart contracts uh, do not, in most jurisdictions, they don't have a legal entity. So it's code that runs on the blockchain and enforces specific actions based on specific predetermined events. Um, but in term in com compared to legal contracts, they are much simpler and they are not enforceable by law, but instead they're enforceable by code. So who controls a smart contract after deployment? So once the smart contract goes live, it lives on the blockchain. In some cases, there are specific features such as upgradability within the smart contract, but many of them are also immutable. Who is legally liable if a smart contract causes financial loss or fails? So, so these questions are very interesting. They are nowadays at the heart of an area called RegTech, which has to do with regulation of technology. So new regulations that try to address the need of protecting the users of these technologies. Um, and we have a long way to go. The problem here is quite similar with a more common example is that of autonomous driving. So you can think of a car that drives by itself and there is an accident. Who is responsible? And there is a very big area in law that tries to determine this kind of accountability, etc. So again, the regulations can vary from one country to another. And this is also my answer to the next question about whether regulators recognize this agreement as enforceable. Currently, we are at the stage where regulators, yes, they understand that people are exposed to risks with smart contracts and other blockchain based facilities, let's say. And also, we are at a stage where they try to understand the risks. The next step is to have the regulations in place. And I think there are two forces that might speed up such regulations. The first is the growth of stable coins and the adoption of stable coins as well as tokenization. So now we have institutions actively experimenting with them. The second is AI. So the similarity here is that you don't have a human leading or being responsible for the action or uh, having or there are issues with something being autonomous compared to being done by a human. So there is this similarity. So with smart contracts and AI, you have code. If there are issues, who is responsible? So I think AI, along with tokenization of stablecoins, will push regulators to act sooner than later. Who audits smart contracts and how reliable are those audits? So there are specific cybersecurity firms. A nice story. Back in 2017, where we had one of the bull market runs in 2017, 2018, and we had many new tokens and projects every day. So I can recall that people would pay like $500 or $1,000 to have very small companies audit their smart contracts. And when they announce that auditing is complete and the token is safe, then the price would appreciate. Nowadays, we have specialized cybersecurity firms responsible for that. Reliability can vary depending on the tools and the experience, etc. Like it's like normal auditing. So Lazar asks, is it really true that no single entity controls the code in dApps? Any dApp running on Ethereum and other blockchain has a team behind it, someone who wrote code and published it, someone who does maintenance. That's how we get software upgrades in Web3 wallets. Can you name one dApp where no single entity controls the code? Okay. So I think Lazar refers to a point I made in one of the slides in the pre-recorded lecture, which had this quote, but in front of it, it mentioned that most dApps are open source. So by no single entity controls the code, I do not mean that nobody will control the code in the dApp. I mean that there is usually not a single one. There will be many. There will be a team, and there will be other people, coders that actively contribute. So by no single entity controls the code, I mean that the code is usually open source. Ecosystem tokens and adoption. So in this lecture, we compare the two account models. From a user growth perspective, managing seed phrases is still a huge barrier for 99% of people. Yes, it is, and uh, such issues actually deteriorate consumer experience, user experience, and they are one of the reasons that we haven't seen as large adoption in payments and other areas of blockchain. With the rise of AI, do you think account abstraction combined with AI will finally make the wallet invisible? Will we reach a point when users don't even know that they are using a blockchain because an AI assistant is managing their gas and private keys in the background? We already have reached this point. So it's very easy to have an AI agent create such a wallet and then use uh, the LLM and give directions. So already this can be done. I don't know if there are specific, specialized, focused apps that do that, but myself, with very limited experience in coding, I'm pretty sure that I can use an AI agent to vibe code that and have this function if I want. Does this improve user experience? It does. Does it affect decentralization? I think it also does. So you now introduce an intermediary. That's the AI agent, the AI assistant. You have to be very careful about that because we know that AI agents are prone to errors. We know that there can be what we call agency costs, conflicts of interest between you and your agent. So I will leave this question open. So maybe George will cover this in more detail in week 12, when he covers future trends. And he also talks about AI. But I think this is a nice question to have in your back of your mind. Is this kind of, let's say, convenience worth the risk? Okay. And this does not only apply to blockchain, it applies to other areas where AI agents are used. And again, this is an exciting area to follow, the intersection of blockchain and AI. How are tokens created and by whom? So tokens are based on smart contracts deployed on in Ethereum. Uh, Nowadays, it is easier to create such smart contracts, and these contracts actually set, for example, the circulating supply, other features of the token, and they are based on standards such as ERC20, which is the most popular kind of standard. Um, these come from the Ethereum improvement, from specific Ethereum improvement proposals, EIPs. It seems to me that tokenizing real-world assets is a very obvious use case for Ethereum. It is. I mentioned New York Stock Exchange, actively interested in having a trading facility for tokenized real-world assets. Um, Last week, the Securities and Exchange Commission in the US, the key regulator, had a very nice Q&A where they said they confirmed the first of all the value for tokenization, which is now universally accepted, and the benefits that it offers. Um, and also their intent to provide more guidance and eventually regulation on that. So why the slow pace in adoption? New technologies take time, especially when there are legal and regulatory obstacles. Uh, but yeah, so this is true for any type of technology. Adoption can be slow. So I think the microwave oven was invented in the 40s. It wasn't until the late 80s, so between the late 70s and the late 80s, it went from 10% to 90%. Its adoption. They take time and they need specific catalysts. But now that we have regulations in place in many developed countries, also we have regulations coming in developing countries as well, which my view is that such technologies have even greater value in terms of financial accessibility, inclusion, etc. While at the same time, institutions adopt these technologies, adopt tokenization, we will see this grow. There are many alternative layer ones that claim insane performance, yet they don't get any traction. What would a smaller layer one need to provide to have a chance of getting popular? Okay, so we've seen with blockchain networks that there is this strong first movers advantage. The a blockchain network becomes live. And if it's one of the first, it will attract a lot of developers that will work on this network, they will become familiar with it, and a community will be created, and then transition to another community gets harder. But what would it take? I would say you need a big adopter. You need a big adopter of the smaller layer one or many big adopters. And maybe then they have a chance of getting more popular. So if it works as designed, so all ask about the censorship resistant upgrade should improve transparency and credibility of the Ethereum ecosystem overall. Yes, this is the purpose, but in principle, yes, it depends on the implementation and how the incentives are used. If new tokens are introduced in the future and Ethereum virtual machine is dominant, all new tokens should run via Ethereum virtual machine or be able to bridge to it. If not, will the adoption affect its progress and acceptance? Yes, it will. So if you have an established ecosystem and you choose for some reason to go for something else much smaller, then this will affect the progress and acceptance. And we've seen that again and again, and we've seen why, and I covered this in the lecture, why a lot of blockchains have target compatibility with Ethereum. So the other programmable blockchains that we cover, Cardano, Solana, Polkadot, and Tezos, are they considered competitors of Ethereum? Yes, they are competitors. They have specific use cases, as we said. What if they get more popular and defeat or replace Ethereum sometime in the future? Yes, this can happen. Okay. So we've seen that with other tech. So back in 1997, Motorola was such a big mobile phone company. They even issued a 100-year bond. So they were expected to be relevant and go strong for 100 years. How many people have a Motorola phone today? So compliance regulation and AML KYC. Can compliance be coded without compromising openness? So compliance and regulation are covered in detail in another lecture, but I will give you my views and thoughts in some of them. So in terms of having compliance, while ensuring openness and decentralization. This can potentially happen, so verified credentials come to my mind as a way to have compliance in a decentralized manner. Can a smart contract refuse interaction with sanctioned wallets? So this reminds me of credit card networks which have a list of banned sellers, uh, and they do not allow payments to be received by these sellers. So, could we see something similar with smart contracts and sanction wallets? Um, so, in order to achieve that, we would either need to have the list of the wallets sanctioned, programmed before the smart contract goes live and before it is deployed, so it's hardwired in the smart contract, or having an oracle. To explain you what an oracle is, think of a protocol, think of a way, to put it simply, to transfer data, information from the real world into the blockchain. This is what an oracle is. Super useful with some stable coins and some other DeFi protocols. So you will need a kind of oracle which will constantly transfer the list of sanction wallets to the smart contract, and then the smart contract, yes, indeed, can refuse interaction. How can AML and KYC obligations be implemented in decentralized systems? You'll cover this in detail in another lecture, so you can think of decentralized identity as a way. So are DeFi protocols subject to financial regulation, and how do regulators approach decentralized autonomous organizations? Two excellent questions by Gabriela. Uh, As I mentioned, there is a strong effort first to understand them. And when I say understand them from a regulatory point of view, understand the risks and the dangers with these products, with these services, with these facilities. But in terms of actual regulation, there is a little bit. So if I am to speculate on that, I could see financial regulation moving towards um, moving towards considering DeFi protocols similar to intermediaries and have similar type of uh, regulations. In terms of how they approach DAOs, they don't approach them at all, so they're much more complicated. We're still trying to understand them, at least at this point. What are the means to control access use of a layer 2 service to avoid illegal activities without very restrictive processes when it comes to know your client or know your. So in terms of means, I think uh, so. One such mean that I can think can be is related to reputations. So you can observe and monitor the the user's history on chain and how they interact with the wallet, and in some case, in some way, try to detect potential illegal activities. Um, some other kind of uh, that it's hybrid approach, you might ask for some selective disclosure uh, of relative information, and maybe that way you can achieve that. Um, or decentralized identity, which again will be covered in another lecture. How to understand the legal and regulatory requirements of blockchain? Is it varied between country to country? Is there any common framework? Okay, so there is not a common framework. I think there are some organizations that operate globally, but in general, it varies between country to country. So I don't know if Andreas or Labis can hear me, or Katerina. I would so if you don't mind Googling um, so there's a recent report by PwC on global crypto regulation in 2026. I think that's close to the title. So if you can share the link with the chat or on the Blackboard, it would be great. It gives a great overview of the regulatory requirements all over the world.
Just share the link in the chat, Apostol.
Thank you. Thank you, Labi. Ethereum, so next question by Peter. Ethereum enables various on-chain structures from an anti-financial crime and digital forensic perspective. How do these structures affect attribution control and network analysis when tracing potential illicit flows? So when it comes to something that lives on chain, so it doesn't use uh, off-chain or more private chains, there is more transparency and a higher chance of detecting such flows. But in most of the cases, you need, when it comes to forensics and crime, you need to combine on-chain and off-chain information. It's not that easy. But if we take into consideration other types of facilities in the Ethereum ecosystem, such as zero knowledge proofs and rollups and uh, uh, specific more private facilities, then it can be much harder. And yeah, so this is also related to the last question about layer two solutions, bridges, etc. Ethereum upgrades such as Byzantium and Constantinople use historical references. So beyond branding, how do these protocol upgrades relate to consensus resilience and network security? Do they alter risk surfaces? Yes, they do. But this is mostly from a governance rather than anti-financial crime perspective. So the issue with anti-financial crime or financial crime uh, is that blockchain by itself is agnostic to a large extent. It is open, it is decentralized. So it's not hardwired to detect financial crime. And I'm talking about permissionless blockchain. So you need other types of more centralized approaches for that. There are always trade-offs. But since I mentioned trade-offs, so most upgrades try to play with this trilemma, and they change the weights on decentralization, security, and scalability. So we have 5 more minutes. I will cover a few questions related to scalability, maybe one or two of them, because we're running out of time. And as I mentioned, there is more coverage um, in in week 11. The volume of contract accounts will likely increase, and these contract accounts operate a large number of operations. Is there a risk of saturation of traditional chains like Ethereum? And so other blockchains should be used where speed is a key criteria. So part of the Ethereum account is to make block space more efficiently used, to make it cheaper, and also outsource some of the transactions of the chain. So I think the Ethereum community has a very clear vision with regards to scalability. They're also flexible and they can change quickly. So I don't see this as a big risk. So, so session three mentions that layer two is the solution for scalability, but many layer twos today are still quite centralized because of their sequencers. Um, Again, this was also highlighted in that quote from Vitalik Buterin. Looking at the AI trend, if we expect millions of AI agents to be the primary users of Web3 in the future, do you think we should prioritize absolute decentralization, or is it okay to accept some level of centralization? So, in general, my view, and I explored this view in much detail in in another course of the MSc, Blockchain and Digital Currency. We have another course which is called Open and Decentralized Financial System. And in that course, our approach is that full centralization and full decentralization are almost never optimal. There are very few exceptions where these extremes are optimal. We see decentralization as a spectrum. Based on what you want to achieve, you might come closer or further away from full decentralization. So it remains to see, uh, but some level of centralization, I mean, I can see it still be there in almost all applications of blockchain. I'm talking here about mainstream applications. Won't the Ethereum price automatically go down as the Ethereum network becomes more efficient? Not necessarily. If it becomes more efficient, we can have more users, larger demand for Ethereum. So we don't take a stance on whether it's a good or a bad investment. But yeah, so if it becomes more efficient, I expect the demand to go up. So who knows what happens to the price? How does Bitcoin's layer 2 compared to Ethereum's layer 2? We'll cover that in week 11. And then another question, is there a risk? And I close with that actually. As I said, the rest of the questions are probably going to be covered in week 11 when we focus on scalability. So is there a risk that layer 1 becomes merely a settlement layer for whales and institutions, losing its direct utility for the average user due to security-related fees? I think it was Vitalik Buterin or someone else, a prominent figure, that said that the goal of Ethereum should be to become boring. Okay, if it works as intended and achieves its goals, it should be something boring where it acts as a settlement layer, the ultimate settlement layer, and then you have rollups and other facilities handling other activities. Okay. Uh, so if it becomes a settlement layer, great. We can also think of modular blockchains where each blockchain handles, you have two, three, four blockchains communicating with each other, and one is just a settlement layer, another handles executions, etc. Again, more on this in advanced topics in Web 3. So this completes the Q&A. Thank you all for your attention. Um, uh, Andrea, Labi, do you have something else to cover?
No, I don't think so. I think we did an excellent job of going over everything on time.
Great, great. Thanks a lot. And thank you all for your attendance. I will see you again in week 6, where we focus on on many exciting developments around prediction markets. So we will cover this with Lampis. Okay. So nice to see you all. Keep in touch, and I'll see you in 3 weeks' time.